Hi everyone, Wilfred here. I take this opportunity before anything to thank you for supporting me, for supporting this channel, and to all my existing subscribers, thank you. And to my new subscribers who are still here to subscribe and who have joined us recently, thank you. Kindly consider to share this channel widely, comment if there's anything you need to be helped with. Kindly consider to just comment in the comment section and I'll be able to attend to it. Help me to share this widely to reach at least 1,000 subscribers. Thank you. Now, as you can see from my screen, uh, based on my poster, in today's video, I'm going to show you on how to generate a synthetic data in Stata for regression analysis. Okay, we'll make this data. We'll make sure that this data is standardized and it meets the normality assumptions. So perfect for testing models and or simulations. That's the goal of this video. So as you can see from just a definition of synthetic data, you can see it's just an artificially generated data that mimics the structure and the statistical properties of real-world data without revealing any actual personal or sensitive information. So like if you are going to use this kind of data, if you are doing a research on something and I don't want to use sensitive data that at the end of the day maybe might cost you, like in terms of maybe you need to do some some ethical approval, then this is the way to go. Like you can just generate this synthetic data and you are good to go with your research or your models. So when is synthetic data useful? Number one, in developing or demonstrating statistical methods, e.g. regression, you're going to do. So if you are teaching or training data science or econometrics, so this method or this approach is best for you. Or if you are prototyping data pipelines before applying to real data sets. So it's a kind of if prototyping or what we call piloting. So and lastly, if you want to meet model assumptions for theoretical model testing, remember in analysis or in research, we assume that there's an assumption that the data has to be normal or it has to meet some of the assumptions, including linearity. If you are doing a regression analysis, normality, yeah. So that's the basic assumptions. And why use lastly is next is why use synthetic data. Number one, it's just safe for experimentation, no privacy or ethical concerns. So you don't need to do some some proposals, writing some letters so that you can be able to get access to that data. So it's just safe for experimentation. So ideal for testing models. So you want to validate regression, you can be able to validate regression model, machine learning, or statistical workflows with this synthetic data. So that's how useful this data is. The next, it is flexible and reproducible. So easily controlled and regenerated. Remember, it is just a random data. Then lastly, it can be used as educational tool. So great for teaching concepts without requiring real data. So that's some theoretical background about this synthetic data. And now I'm going to use Stata to take you through step by step on how to generate it. But if you need any help with the research or statistic, if you need support in statistical research and consulting, thesis and academic research support, training, workshops, and upskilling, kindly consider to email. You can email me. You can consider my service. So just email me. The email is at the analyst wilfred@gmail.com. So let us take your research to the next step. So welcome to now Stata, where I'll be doing these steps step by step. So what do you need? So the only thing you need here is a Stata. You can have any version of Stata. So you can see this is my start window, my command window, variable window, variables window, and so on. And this is my do file. So this is where I'll be creating this data step by step. Now let us get started. So step one, let me call this as step one. Step one, I need to set the sample size. So sample size is so important. So set sample size like that. So, and in this case, I want to use 1,000 observations. So what I need to do, I'll create clear all, so to ensure that I've cleared everything from the memory. And it's good to get to control. Remember, this data is a random data. So if you regenerate, actually it will bring different values as depending on how many times you generate that kind of that code. So to control that, you can set seed. So you can input any value. So let me just say 1, 2, 3, 4, like that. Next, let's set the number of observations or the sample size 1,000. So you can set any. If you want different 500,000 observations, so you can just set at that point. So with these three codes, what they do, number one, we create the data and they create another set with 1,000 observations. So if I do that and execute, now you'll be able to see the number of observations 0. 0 was 0, now 100,000, because we cleared everything. So if I click browse, I'll be able to see. Now if you look at the browse, you'll be able to see it's empty, but it has 0 variables and 1,000 observations. So now we need to fill up this kind of observation. So we need to generate them. Good. Now the second step, which is now step 2, is to now generate. You have to generate a normally disputed independent variables. Remember, in regression analysis, we need to have independent variables and dependent variables. So we need the independent. So I can just say generate x1, that's independent variable 1, is equals to, so r normal. So r normal just mean that the random normal. So normal 0, 1. So what does this 0, 1 mean? So this means that when we do the standardization of the data, we set it in such a way that it has a mean of 0 and a standard deviation of 1. So it means here, when we are going to create this data, it has to be standardized within that rule, with a mean of 0 and a standard deviation of what? Of 1. So I can just copy this, paste here. So this is my x2. Let us say I need 3 independent variables. Yeah, with the same concept like that. Now we have generated, now we generate 3 independent variables drawn from standard normal distribution with a mean of 0 and a standard deviation of 1. So I highlight this and execute. See, now the variables are being generated, and if I go back to my data, and you'll be able to see the variables here. Now this is the variables that we have just generated from that code. So 3 variables, 1,000 observations. So if I go back and I do just a sum of those variables, you can be able to see the mean. Let us see, the mean is negative 0.000. It's so small. So you can just round off this to 0. You can see 0, 0. This one, you can be able to see to 1 decimal place. You can find that now this is 1, this is 1, this is 1. So it is within the standard normal distribution. Yeah. Now next, let us move to next step. We are generating now the dependent variable. So next step, that is step 3. Generate. All right. Generate, create create error term and the dependent variable. So we use the same concept. So I can just create that. So error term, I can just give it this symbol error term within the standard. Then I regenerate my y, which is the dependent variable, with some I'm generating this y with some linear model based on the linear model with the known coefficients. So you can put any coefficient at this point. So let me go with 2, then plus 0.5. So you multiply with x1, then minus 0.3, you multiply x2 plus 0.2, you multiply x3, then you add the error term that we have just generated above here. So once you are through with that, highlight and execute. So you can see here we have the output, and if I go back to my data, now our data is complete. We have the y and the independent variables. So we have 5 variables at this point. Good. Now let us move to the next step. Now the next step, we need to check the normality of this data that we have generated. Is it normally data? Is this a normal data? Is this normally disputed? So next step, yeah, let me call it step 4. Check normality. So what I do, I can use an histogram. Then I use this y, comma, then I call it. So it will be an histogram with a normal curve. I do that and I execute. So if once I execute, now I'll be able to have an histogram with a normal curve. So looking at this histogram with the curve, you can be able to see it is actually somehow normal, but not that not that's perfect, like not perfect. It's not that perfect in terms of normal. Or you can use what we call Shaviro-Wilk test. So there's another command we call you can use Shaviro-Wilk test. And this command is just that we use that command, then you list the variables. So can put the y and execute. So how does this work? Now based on this, you can see we have the observation, interpret the statistic, then we have the v, we have the c, and we have the p value. Now we normally say the data is normally disputed when the p value is greater than 0.05. So if the assumption, the hypothesis is, the null hypothesis is the data is normally disputed, or the data is normal. Then the alternative, the data is non-normal. So if the p value is greater than 0.05, then we fail to reject the null hypothesis. And the null hypothesis states that the data is normal. So at this stage, we can say that our data is normal since the p value is 0.72. So you have said that. Now let us step 5. Let us standardize now these variables. Standardize the variables. Standardize the variables. What's using now the z-scores. This is normally what's being used. So we are going to use the z-scores like that. So now in this case, remember from the initially we used generate command to generate the new variables, but during the standardization now we'll use the the agent function. We call it agent function. Now with this the standard deviation. So now what we do, you do agent like that. So you can go to set x1 you have already created, then is equals to standard deviation of x1 like that. Then so we do that to the rest of the independent variables. So we have x2, so we replace here this x2 like that, x2. Then we move to the last independent variable, which is x3, then x3, and our let us start with our y, all right, the dependent variable like that, like that. So now I write and execute. So if I do that now and I go back to my and I go back to my back to my data, now I'll be able to have, now you see we have the standardized variables and now the one that we had from initially. But now for our now subsequent analysis, now we'll be using the standardized data. So not the one with x1, x, so we'll be using the one with set score. So you can also you can try to filter the variables to make your work easy, so to avoid. So I can just say keep. So I want to keep these standardized variables. So once you do this command, what it does is that it only pick those variables that you are interested, then the rest are being dropped automatic. So just put it here and I do that. So you can see now we have only 4 variables. So if I go back to my data, I can be able to see only the standardized variables with 1,000 observations and 4 variables. Good. Now I can be able to just do a quick summary of that data. So I can have a summary, extend this. So if I have this summary, let me create this and have some, yeah. So you can be able to see now we have, remember initially you saw that the standard deviation was 0.9596 when we were rounding off at least to 1. It was not properly or it was not fully standardized. But now with the standardization, now this data is within the range of 0 and 1, a mean of 0 and standard deviation of 1. So you can be able to see 1, 1, perfect 1. So there's no rounding off or anything. But you can see this is a small number. It's just a perfect 0. 0, 0, 0, then 1. So if I can go back again and test the normality of this data, you can be able to see now a perfect histogram. Look at this. From -4 to 4. So it is not, this data now is normally disputed. And if I can include the normal curve, if I can include the normal curve like that, you see, so it is perfectly the normal. So I can even move to the other variables. I mean using the Shaviro-Wilk test and based on all the variables and press enter. You see, so this is the b value for all the 4 variables, and you can see all the variables they reported a b value greater than 0.05. So then at this point we fail to reject the null hypothesis and conclude that this data is normal. So that's what we have done up to that point. So once we have this data, you can be able to save this data. So you can just go here and save, you can save this as save normal, it's normal data dot dta like that. So you can save like that. So this one now will be saved or to your folder where you put this, maybe the do file. Also You can import it to Excel. Now, if you are actually, you can use this if you are going to do some predictive models, maybe using Python, R, and maybe you are not, you are good maybe in Stata, but in terms of generating the data, you can import this back sorry, you can import this back to Excel file. So you just come, you just click Excel spreadsheet, and now it will give you this option. So you browse the folder where you want to put it, and you just press OK, and it will import. And also you remember to tick this import first rows as variables, variable names, so it will preserve the variable keys at that point. Then if you browse this, like in my case, I want to put it in desktop. Let us say in that synthetic data, or let me create this folder here, normal data, normal data, data, like that. So I'll open this and I call this data as normal underscore data. I click open. Sorry. Sorry, I go here. Excel. So call it normal. Okay, let me go here. Sorry. Can you go back here? Move this to Excel. Sorry, not import. Sorry, we have to export. Not importing. So we have to export from now. Stata to Excel data. So you use export, not import option, like that. So variables, you have empty for variables. Then your file name, you can call it no more data, like that. So can you click save variable names first row, just tick that. You can save this, go to desktop, no more data, yeah, and click this as no more data, like that. So it will work, and click save, and click OK. Good. So now the data has been saved as a no more data dot xrs file. So you can take now this Excel file and you do with anything, maybe modeling, like predict models and so on. Now the last thing we need to do is regression analysis. So we can just click regression, the dependent variable, independent variables, like that, and we press enter. So we'll be have a regression analysis. This is the table now, and you can be able to see the coefficients, the standard data, the p-values, and the r squared as well, which is there. So you can be able to see now this data from the synthetic data. We are able now to run regression analysis with the standardized variables, which we know at the back of our mind that this data is normally disputed. So up to this point, this is what I wanted us to run today, and I hope this video is helpful to you and you have learned something from this. Kindly, if you have anything and question, any burning issue, just leave it in a comment section. And if there is any improvement that we need to make, so as to help this journey to grow, and also the community in terms of the subscribers, you can also recommend. Thank you. See you next time.